Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Mastering Data Structures and Algorithm in Java series. Today's data structure is matrix. This is part 1 where we'll discuss the theory and fundamentals of matrix. Okay. So as many of you would already know, matrix is nothing but a 2D array. Okay. If you go with the definition, a 2D array or matrix is a data structure that stores elements in grid format with rows and columns. Purpose: used for representing grids, tables, images, game boards, etc. Right? We can see this is a two-dimensional array. We can store the values here, throughout the row and then throughout the columns as well. Right? So if we go a little deeper, not deeper but 2D array. Okay, we have already covered array. If you are unclear with that, please go through the video on the arrays. Okay, for generally, let's say if I have to store 1 2 3 4, we pick one array where we store them with the indexing 1 2 3 4. This is how we'll store it in a 1D array. This the indexes will be 0 1 2 3, right? Now we want to store something in the 2D array and it looks like something like this. Let's say 1 2 3 4 5 6 7 8 9. Okay, so we'll store them in a 2D array. We'll create 2D array for this. We can say 1 oops yeah, we can say 1 2 3 4 5 6 7 8 9. Now in comparison, as we see, this is the index, right? For arrays, these are rows, right? Rows, and these are columns. So we have two indexes. One index is for traversing the row, then another index for traversing the column. So we generally, for index here, we represent them by I, right? So let's say for this 1D array, the array name was array. So if you want any element, we can directly say array of 2. That will fetch us 0 1 2 on the second index, value 3. So array index of 2 will be 3. Here in this case, if you want to fetch any value, let's say the name of this two-dimensional array or the matrix is mat. So we can say mat of 2 2 is equal to, so indexes here for the rows are 0 1 2. Similarly for columns we have 0 1 2. These are the indexes for the columns and this is the index for the rows, right? Because rows are here. So this is the 0th row, first row, second row, 0th column, first column, second column, 0th column, first column, second column. We are looking for a matrix in 2 2. So we go 0 1 2 and then in 2 we get 0 1 2. This is 2 cross 2, this element, right? So we get the value 9 here. Similarly, if we do mat 0 0, we'll get the first element, that is 1. Similarly, we can get the other values at mat 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2 and like that, right? So this is a 2D array or the matrix we usually use. Now this is used in a lot of application when you have problems on two-dimensional arrays, plus if you have to store something like a Sudoku. Sudoku is again a 2D array, right? It can be stored in two-dimensional manner. Plus let's say you want to store something like tic-tac-toe, the values of tic-tac-toe in suppose you are writing an application for tic-tac-toe, right? Cross 0 cross 0 cross. These things also you can do in 2D array, right? So let's go back. Now we understood what is 2D array, that is what is matrix. It is nothing but a 2D array, and what it looks like this, right? Let's go further. So on the declaration and the initialization side, we can initialize it just like we used to initialize an array. We can simply initialize, we can call it matrix, we define the new size. Similarly, we can do it for string, and similarly we can directly declare it with the initialization of the values as well. Let's look at the code example. Okay, so we'll quickly create the code example for it as well. We've got Java class, let's call it matrix. Let's see, everything is working fine. Public static void main, oops, string args. Okay, system.out. We have to make sure that everything is working fine before adding code. So let's see. Okay, it's working. Now, as we saw, right, how can we declare matrix? We can declare directly like this, or we can declare them with the initialization as well, right? So let's see. If we have to do, we can say, we'll say int. It's two-dimensional, that's why these square brackets are 2 times, right? Matrix is equal to new int, right? And we can give the values, say 2 and 2. If we were declaring an array, we would do something like int array is equal to new int, right? This is how we used to do for an array, and this is how we do it for the matrix, that is two-dimensional array, nothing but, right? So only one extra square brackets, that is for rows and columns. Earlier we only had rows, right? Let's remove this one, we don't need it. Similarly, if we want to do it for string, we can do string instead of int. Let's call it matrix2 new string, and that's it, right? We can give the values 3 3. Okay, similarly, if you want to initialize with the values, so we'll say int, we'll call the matrix3 is equal to new int, or directly the values, we'll say 1 2 3, then 4 5 6, right? This is a matrix of the form 2:3, right? Now let's go back to the presentation. Okay, let's go next. For accessing elements, we can directly access the elements, and similarly we can iterate through an element. For accessing elements, as we saw, right, we have this array 1 2 3 4 5 6. We want to access any element here, let's say. So we can, if you want to access this element, we'll say mat, and we need this element, right? So this is in the zeroth row and first column. So mat 0 1 should be equal to 2. Okay, let's create this example. Okay, have we created the example? We have created the example of 1 2 3 4 5 6. Okay, so let's go with that example, so that it will at least be clear for us what is row, what is column, because it's a lot of time a lot confusing. So let's understand it. So we have the values 1 2 3 4 5 and 6. Okay, now let's say we want to print this value. So these are the rows. So this is row 0, this is row 1, this is column 0, column 1 and column 2. So if you want to print this value, it comes on index 0 1 0 1 2. So it will be mat of 0, sorry, not 0, row first. So mat of 1 1, but 1 1 would be not good, right? So let's instead of this one, let's not print this one. Instead let's print this one. Okay, so at least rows and column value would be different. So we'll print it like, we'll say mat, it should be 0 2, right? Let's see if it should be 0 2 or should it be 2 0, right? Let's check. So we'll say int value is equal to matrix 3 0 2, and then we'll print the value system.out.println. Let's call it complete value instead of just value. Okay, let's run it. We have 3, right? So when we are doing 0 to 0 is the 0th row, and second is the third element, that is second column, 0th column, first column, second column, right? Because indexing, whether it's 1D array or 2D array, it always starts with 0. Now let's say we want to print this one. So this one should be mat 1 0, because this is 0 1, row number 1, so second row but on the indexing 1, and column, first column but on the indexing 0th column. So first is the row, second is the column, always, right? So let's try for 1 0. 1 0 should fetch us 4. Let's try that. 1 and 0. Let's run it. 1 0 fetches us 4. Okay, cool. Now let's iterate through the array. Iterate through the 2D array or the matrix. If you remember when earlier we want to iterate over an array, how we generally used to do it is, we'll write a simple for loop for int I is equal to 0, I is less than array dot length I plus plus I plus plus, and inside we'll simply print the value array of I, right? This was the code for printing value or for traversing through the array. Now we want to traverse the 2D array, so it should not be that different from 1D array, right? Because array or matrix, array is 1D array, matrix is 2D array. Now for this one, how we'll do it is, we'll say for we want to traverse the rows, and then in the row, after traversing the complete row by row, in each row we want to traverse column by column. So we can say int I is equal to 0, I is less than matrix dot length I plus plus. So matrix dot length will always give us the row length. We'll confirm this as well. And once we are traversing a row 1 by 1, 1 2 3, then we want to traverse column as well, right? So we'll create another for loop for int j is equal to 0, j is less than matrix of I, that is I comes from here, I dot length j plus plus. So, and then here we can simply print the values like matrix I j, simple, right? This is how we can traverse the 2D matrix, 2D array or matrix, and this is how we used to traverse array 2D array, right? Not much change, extra for loop. Now let's go and see this with the example. Okay, what can we do? Okay, let's traverse the array. We'll say for int I is equal to 0, I is less than matrix 3 dot length I plus plus. Right, now inside this we need another array. For int j is equal to 0, j is less than matrix 3 of I, that is row dot length. So this is traversing the row. Now we are saying for each of the row, let's traverse the columns as well, j plus plus. Now we'll say system dot out dot println, let's print the value matrix 3 I j. Okay, let's remove this one. Okay, let's run. So what do we see? We first printed 1, then 2, then 3, right? So then 4, then 5, then 6. Okay, let's quickly look at it. We first printed this. So if you see, we traversed the complete row and we printed the column values. So we are traversing the row. This is the row 1, 2, 1, 2, 3. The values like this, right? And once we printed the first row, we went to the second row, and then 4, 5, and 6. So this for loop is for traversing the rows. So when we say, or let me explain this point in better manner. Okay, it will be much helpful. Let's say, so we had the values 1, 2, 3, or not like this. Let's make the matrix first. Okay, we had 1, 2, 3, 4, 5, and 6. Okay, simple. Now we are saying this is first row, we call it R0. This is second row, we call it R1. Column 0, column 1, column 2. Indexes for rows starts from 0, 1 for column 0, 1, 2, right? Now we wrote the code for traversing as for int I is equal to 0, I is less than matrix dot length I plus plus. Inside for int j is equal to 0, j is less than matrix of I dot length j plus plus, and then here we can keep our SOP, system dot out dot println. Now if you see I value 0, I is going to run matrix dot length, so it will only run till I equal to 0, then I equal to 1. Okay, this one is traversing the rows. This for loop is traversing the rows. Okay, so the value is only going to change between 0 and 1. First 0th row and then first row. Now first when I is equal to 0, so we are in the 0th row. We are saying another loop is starting. I is equal to 0, I less than matrix dot length I plus plus, but plus plus hasn't happened. We came in, we saw for int j equal to 0. Now j is equal to 0, j is less than matrix of I, that is matrix of I, this one dot length. Okay, so it picked this and the length would be 3, matrix of I dot length. So this will give us the length of the column. Now we are saying SOP, let's say we are printing the value. We'll say matrix I j. Now here value of I is equal to 0, value of j is also 0, so 1 gets printed. Then value j plus plus, I is not increased, j plus plus, so i's value is 0, j value becomes 1, we print 0, 1, right? 0th row first column, so 2 gets printed. Then 0th row second column, 3 gets printed because j plus plus. After this j plus plus, j becomes 4, 4 is less than matrix I of dot length, no, because this length is 3, this length is 2. So loop breaks here, it goes out, I plus plus, I becomes, earlier I was 0, now I becomes 1. Again for 1 it starts, j is equal to 0, now I is equal to 1, j is equal to 0. So 1, row number 1, that is index 1 row, that is second row actually, I is equal to 1, j is equal to 0. So we get 4. 4 gets printed. Then again j plus plus, I is 1, j is 2, j is 1. So I1 J1 intersects here. 5 gets printed. Then I1 J2 because j plus plus, and then 6 gets printed. Right? After this j plus plus, j becomes 3. 3 is not less than 3. It breaks. It goes out. I plus plus, I becomes 2. 2 is not less than 2. It breaks. So we print 1, 2, 3, 4, 5, 6. Okay, in this manner, and not because other case could have been printing 1, 4, 2, 5, 3, 6, right? But now that we mentioned, let's do it. Let's check it, right? How will we print column wise first? I want to print by column, but we do not have any variable for the length, right? But let's either you guys explain this to me in the comments, that how will you print the values 1, 4, 2, 5, 3, 6. Okay, you have to print this value. Please think about it, and when you get the logic for it, it's a really easy and beautiful logic. Once you get the logic for it, please let me know in the comment section. Okay, and let's fight for this in the comments. Okay, now moving on, we did the declaration and initialization, matrix accessing elements, we iterated through it, and now let's do a simple code example on this. Okay, in the matrix we have to find the sum of all the elements. Okay, so we have let's remove all of this. Okay, we have this matrix. One, 2, 3, 4, 5, 6. We have to traverse the matrix and we have to find the sum of all the values. So sum will be equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. It's a simple problem, right? Because we'll cover complex examples in the part 2. This is just for the understanding the fundamentals, right? So sum is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. This would be 6 plus 4 plus 5 plus 6. This will be 12 plus 4 plus 5, 16 plus 5, 21, right? We should get 21. So how will we do it? We'll simply run for two for loops. We already know. One for loop for the row, one for loop for the columns. Now, but inside we want to add the summation. So we'll create one variable outside, int sum equals to 0, and here we can say sum is equal to sum plus, or let's say it in better manner, sum plus equal to matrix of I, j, for loop ends, for loop end. So we'll traverse this complete matrix, and each value we add to sum. So sum was initially 0, we add 1, then we add 2, then we add 3, we add 4, we add 5, we add 6. Just for simplicity of understanding for everyone, this statement where we are writing sum equal sum plus equals to, and we write anything matrix I, j, this line is same as writing sum is equal to sum plus matrix I, j. Okay, we are using directly plus equal to, but it only means sum equal to sum plus matrix. So it adds the original value and the new value. It's a shortcut. Okay, so let's quickly solve it. Okay, let's create another loop for this. So we'll say int sum is equal to 0. For int I is equal to 0, I is less than matrix 3 dot length I plus plus. Okay, again for int j is equal to 0, j is less than matrix 3 dot matrix 3 of I dot length j plus plus. Okay, and we can say sum plus equal to matrix 3 of I j. Okay, and then in the end we'll just simply print the value system.out.println sum plus sum. Okay, let's run it. Let's see. So we can see sum is equal to 21. Right? I hope this was clear. We'll be solving a little complex problems on the 2D array in the second part. So I hope 2D array is clear to everyone. Right? Now, just for the understanding and just for so that it's clear to everyone how arrays work, we'll simply look at one 3D array as well, right? If you can see, a 3D array is like a cube. If you imagine 1D array as a single line, you imagine 2D array as a cuboid, or not cuboid, square or rectangle, and you can see 3D array as a cube, right? So 3D is an array of arrays, that is correct, representing a cube of element, used for storing and manipulating three-dimensional data such as voxel grids in 3D graphics. Okay, we can initialize it just like this: int, cube, new int. Earlier we used to have single square bracket for arrays that are actually 1D arrays, 2D, 2 square brackets for matrices that are actually 2D arrays, and 3 square brackets for 3D arrays. Similarly, you can, if you understand this principle, you can understand that you can have n number of you can have nd array as well. N would be a variable like 4D array, 5D array, 6D array, 7D array, and like that. Now if you want to understand in simpler manner, let's look at it like something like this. Let me delete a little. I don't want to delete everything just in case we need it again. Okay, now let's look at it here. Imagine so if you want to store value 1 2 3, we can store them like this: 1 2 3. If you see this is nothing but a simple line, right? If you want to store more values, we can create a square. It's 1 2 3 4 5 6 7 8 9, and now this looks something like a square. Now we go for 3D array. You actually store values, it would look something like this. Okay, this is just for imagining it, because we cannot imagine the 4D array, the 5D array, the 6D array and all, right? But we will have grids of grids. And then we can have one here, there will be value behind this, there will be values on the right, this side, there will be values on the left side, and all. Okay, this is just as just a representation to understand how 3D array looks like, or what 3D array looks like, right? But you have to imagine 1D array, that is very clear, 2D array, that is very clear. 3D array is nothing but array of arrays. If you see, this is array, this is array of arrays, right? Because in each column, okay, so let's look at it like this. This is an array, We'll look at it like this. There is a box, and inside that we have 3 values, 1, 2, 3. Now again there is another box. Inside that we have values like 1, 4, 7, comma 2, 5, 8, comma 3, 6, 9. Right? These are the values being stored in the first array. Now internally this is an array again. Now what if the first one is an array again, and it will look something like this, that we have this and we have 1, 6, 9, 4, 7, 2, 7, 3, 1, comma, now this is one part, again we have 2, 1, 9, 5, 6, 3, any values, right? 6, 4, 9, this is second, again a comma, and we have 3, 6, 9, 6, 2, 1, 9, 4, 7, and this is third, and this square bracket. Okay, so we saw this square bracket, it has 3 elements, 1, 2, 3. We saw this square brackets, again it has 3 elements, 1, 2, 3, which in turn are 3 arrays. So now this becomes array of arrays, 1, 2, 3. This is 1D array, this is 2D array or the matrices, and this is 3D array. Now again in the square brackets we have 1, but 1 internally has array which is 1, 4, 7, like this, 1, 4, 7, but each of those elements have an array of itself as well. 1, 6, 9, 4, 7, 2, and 7, 3, 1. And then this again is an array. So this is an array of arrays. This is an array of arrays. This is an array of arrays. But the outer one, now it will be of array of arrays. 3-dimensional array. Similarly, you can imagine the same for 4D, 5D, 6D, and ND. Right? So this was just in case for you to understand how you can extrapolate your understanding from 1D array, matrices, that is 2D array, 3D array, to ND arrays. Okay, so that's all from this video, everyone. For anything, please let me know in the comment section. And if you like the video, please like, share, and subscribe. Thank you.